6 is done, right?
Yes.
After 6, which one?
Number 7.
Number 7.
Yes.
Okay. So this one is related to the idea we are using high voltage in the grid lines, right?
Yes.
And using alternating current, what is the benefits? So for using high voltage, what is the benefit? It's written in your notes. Check what is written there.
Current will be less.
Current will be
Less.
Current will be less. If current is less, then what is the benefit?
Less energy loss.
So from left side, there are 2 columns, right? So left side column, you should
Yes.
choose either C or D, right?
Yes.
Okay, then alternating current. What is the use of alternating current? Is it the resistance of the cable reduced or the voltage can be changed using a transformer?
Uh, so I think it will be C, resistance.
So it is not written in your notes about alternating current. When we
Yes, sir.
discussed about the transformer, it is written over there at the beginning, you see. What is the use of alternating current in the transformer? In alternating current, we are getting the change in direction, right?
Yes, sir.
So if you are getting change in direction, then you are getting change in magnetic field, which
Yes.
is helping to get induced EMF, right?
Yes.
So primary to secondary, we can change the voltage, right?
Yes.
It is written in your notes, check. At the beginning of transformer, it's written. Isn't it? How the transformer
Yes,
is
sir.
working, that one is written in your notes. So
Yes.
what should be your answer?
Option D.
Dhaka, right?
Yes.
Look, nothing is outside from your notes. Then next,
Next, number 10.
number 10. Yeah. 10 also you did wrong. You learned AC generator graph.
Yes, sir.
So AC generator graph, which one you drew? You have positive and negative voltage, right?
Yes.
So which one is showing here positive negative voltage?
D number.
So why you couldn't get it? Then next,
Uh, 13 number.
13 number. Yeah. This is problem. The conductors attract one another. It's written in your notes.
Yes.
Topic 22 is written. Check. If 2 conductors are attracting each other, then straight 2 wires, they are attracting each other. In which condition? The current must be in the
Same direction.
same direction. So it's there in your notes, right?
Yes.
You forgot. Then next, which one?
16 number.
16 number. Okay. Yes, this one is a tricky question. Uh, this one I'm explaining. Look here, it's written speed of the rotation.
Yes, sir.
The speed of the rotation, if it is increasing, you will get more induced EMF, right?
Yes.
So if it is more induced EMF, then either it can be C or D, right?
Yes, sir.
Now, if you increase the rotation, number of rotation if you are increasing, then number of complete cycles increases every second, right?
Yes, sir.
So which one should be your answer?
Uh, D.
Dhaka,
Yes, sir.
right? So the frequency is more and EMF also more. So right, in 16, you're right, the EMF is more, induced EMF is more, the frequency is also more. Is it clear?
Yes.
Then which next?
Finish.
Huh? Finished.
Yes, sir.
So 18, your answer is Dhaka.
Yes.
The same idea. Okay.
Yes, sir.
The same idea. Look here. Which graph base shows how the output changes? They are saying speed of rotation of coil steadily increases. That means steadily here increases, so the frequency increases, right? And the
Yes, sir.
amplitude also increases.
Yes.
Yeah. Is it clear? Now, structured questions you did which one?
I did till number 3.
Number 3.
Yes.
Okay, very good. Look, question number 1. So why the core of the transformer is made of iron?
Because it is a temporary magnet.
Yes, because it is a temporary magnet. And what happens if it is temporary magnet?
Uh, its magnetic power will go.
Its magnetic power will go. Okay. Okay. So iron is a soft magnetic material
Yes.
which is producing temporary magnet, right?
Yes, sir.
Okay, that's why. Then what is the answer here?
Uh, it will be it changes from positive to negative.
Yeah, so alternating current changes the direction, right?
Yes, sir.
Alternating is also going to positive to negative, but that positive negative always changes direction,
Yes,
right?
sir. Yes,
A
sir.
direct current is going only in one direction.
Yes.
So what should be the appropriate answer? Positive to negative, or alternating current changes direction and direct
Alternating
current
current changes
goes only
direction.
in one direction, right?
Hmm.
Then what is next answer? Next point, 2.
I couldn't write the second one.
You couldn't write the second one. Okay. So alternating current has frequency, right?
Yes, sir.
But direct current does not have any frequency, isn't it?
Yes, sir.
This is one thing. And another thing is alternating current has, amplitude is changing, right?
Yes, sir.
That means alternating current, uh, its voltage is fluctuating, right?
Yes,
Varying.
sir.
So that one is also a very important point. So you write alternating current
Hmm.
uh, has varying current.
Yes, sir.
Alternating current has varying current. Then next which one?
Hmm. Because it does not have electromagnetic induction.
when there is a direct current in the primary coil. So if there is direct current, then
There will be no
what we
need to
need
manage it.
in the secondary,
Yes,
if you want to have any voltage, then we have to have in primary changing magnetic field, right?
yes, sir.
So if there is no changing magnetic field in the primary, then there will be no induced EMF in the secondary,
Yes, sir.
isn't it?
Yes, sir.
So for having a change in magnetic field, we should have alternating current, right?
Yes, sir.
So how can we write the answer? Because direct current does not produce changing magnetic field, right?
Yes, sir. Secondary
Because
magnetic field is constant.
because DC does not produce changing magnetic field. Magnetic field, so there is no,
Sir, I wrote the magnetic field is constant.
yeah, you write this way, that is better.
Okay,
This is
sir.
more specific, so there is no induced EMF. If you write constant, it's okay, but better to write changing magnetic field. Is it clear?
Okay, sir. Yes, sir.
So you wrote,
Yes, sir.
finished?
Yes.
Question number 2, right?
Yes, sir.
I can remove this writing, okay?
Yes.
Okay, read this question. Read the question.
A straight length of copper wire lies horizontally between the poles of U-shaped magnet. Figure 2.1 shows the two ends of wire connected to a very sensitive center 0 ammeter. The copper wire is moved upwards slowly between the two magnetic poles. The needle of the ammeter deflects to the right. Explain why the needle on the ammeter deflects.
Okay, so you could write it, right? This one is very easy. Why the ammeter is deflecting?
Because the wires cut the field lines.
Again,
The wires cut the field lines.
more specific. Magnetic field lines, huh? Where cuts the magnetic
Yes,
field
sir.
lines, then there is induced EMF. Beside induced EMF, you give slash induced current is produced. Have you written?
Yes, sir.
The next. Yeah. B. Read B and tell us the answer.
The wire is moved downwards very quickly between the two magnetic poles. State what happens to the needle on the ammeter. It will change direction.
It will change the
change
direction.
direction.
And what happens?
I wrote this one only.
You wrote only this one, but you should tell me more information. If you are moving quickly, you will get the deflection is also more, right? But in opposite direction.
Hmm.
Is it clear?
Yes,
If
sir.
the movement is quickly, then you are getting more induced EMF, right? More induced current.
Yes, sir.
So then your movement of the needle will be also more. Is it
Yes.
clear?
Yes, sir.
Okay, then see. You write also that point. I just told you. There you write this point also. And the
Yes, sir. I
needle
wrote.
will move more. Okay, then next
Yes.
read it.
State what happens to the needle on the ammeter when the copper wire is moved horizontally between the two poles.
What happens?
I think the current will not be able to pass.
You wrote what? No,
The current
no
current
current,
will
right?
pass. Yes, sir.
No induced EMF. Ah,
Yes.
that's why no movement of the needle, right? Isn't it? They are
Yes.
asking about the needle, right? No,
Yes.
no movement of the needle as there is no induced EMF. As the magnetic field lines are not cut by the coil or wire. So write all these 3 points so that you can remember it later easily. Is it clear? Or I should write?
Yes, sir. Yes, sir.
You have written?
Yes.
Okay, what you have written, tell me.
I couldn't complete it. Can you repeat?
Yeah, you couldn't complete. I'm writing, you write. No movement of the needle as there is no induced EMF or current since magnetic since magnetic field lines are not cut by the wire. Is it clear?
Yes, sir.
Okay. Done, huh? Hello?
Yes, sir.
Okay, then question number 3 also you tried, right?
Yes, sir.
So A1, what is the answer?
It does not have any free electrons to carry the charge.
Again,
It does not have any free electrons to carry the charge.
they don't have any free electrons, right?
Yes, sir.
Okay, very good. Then next,
Next, aluminium is a non-magnetic material.
aluminium is not a magnetic material. Very good. Then iron,
Iron is not a permanent magnet.
iron is a soft magnetic material. You're right.
Yes,
Iron is soft magnetic material. Is it clear?
yes.
The next, read. Read loudly. Tell the answer.
In one experiment, the magnet in figure 3.1 is moved to the left, passes into the solenoid. The north pole of the magnet travels from x to y at constant speed as it moves. The ammeter shows a small current. Explain why there is a current in the solenoid when the magnet is moving.
Okay. So what should be the answer?
I couldn't write this one.
Already we had discussion many times. Just today
I
we
think
did.
I have idea.
Now you write. Tell me first.
Uh, the magnetic field lines will cut the wire and the voltage will be induced.
Here solenoid. Say
Yes,
solenoid. Magnetic field lines are cut by the solenoid, right?
solenoid. Yes,
Yeah. Then there is induced EMF.
voltage will be induced. Yes,
There is induced
induced
EMF.
EMF.
Okay, that is the answer, right? You are
Yes.
having 3 marks.
Hmm.
For these 2 points, you are having 3 marks. First point, you have 2 marks. Then second point, you have 1
Oh,
mark. 3 marks. Okay, done.
yes, sir.
So now you are confident, right? What you have to write?
Yes.
Then next, what is the potential difference across the solenoid?
Hmm. 5.4 into 10 to the power minus 5 volts.
How much it is?
0.054 volts.
0.054 volts.
Yes.
Okay. So is it volts or millivolts? Because
I'm not sure.
your current is given in milliampere.
Oh, then it will be millivolts.
And what is the answer of charge? Hmm?
6.3 into 10 to the power minus 6.
Yes, correct. Then next, continue, read.
In a second experiment, the speed of North Pole is greater than the speed in the first experiment. It only takes 0.07 seconds to travel from Y to X. A current in the same direction is shown on the ammeter. State and explain how the sizes of this current compares with the size of the current in the first experiment.
Okay. So what is the answer here?
More induced EMF and the field lines will
Here current will be double,
change
right?
fast.
The current will be double.
Yes, sir.
They are saying the speed of the North Pole is greater than its speed in the first experiment. So the current will be double, right? Because the charge remains same, but
Yes.
the time is half, isn't it? That's why
Yes,
the
sir.
current will be double. So you write it. The current is double as the charge remains same, but the time is half.
Yes.
Okay, then next.
The same quantity of charge passes through the coil in both the first and second experiment. Explain why this is the case. Because it has more current and less time.
Yes, double the current. You say double the current and half the time. This way, more specific, okay?
Yes. Yes.
Have you written?
Yes, sir.
Okay, D.
State 2 is in which the equipment shown in figure 3.1 can be used to produce the current in the solenoid that's in the opposite direction.
So here is the diagram. If you want to get in opposite direction, current in opposite direction,
Yes.
then
Yes.
it was moved towards the coil. Now what you have to do, the North Pole should be taken away from the coil, right? Isn't it? If you are taking away, you will get opposite direction of the current, isn't it? Hello? Okay. Then another option, you see, what can you do? You can make it reverse, right?
Yes, sir.
Like here we have North Pole, we can take here South Pole, isn't it? If you reverse the magnet, then you can take the South Pole towards the magnet, towards the solenoid. Is it clear? Hello?
Yes, sir.
If you are taking the North
Yes,
Pole
sir.
towards the solenoid, the direction you will get. If you are taking South Pole, you will get opposite direction, right? isn't it?
Yes.
Okay, so what should be the answer? You understand, right?
Yes, sir.
So the first line, what you wrote? First line, what you wrote? Abhir?
And we can remove the North Pole.
Yes, we can remove the North Pole from the solenoid, or we can
Yes.
take away the North Pole from the solenoid. Okay, more specific.
Yes,
You
sir.
make more specific. From where you will remove? From the solenoid, right? Then the second line,
Second line, sir, I couldn't hear you. Can you repeat?
yeah, you write taking the south pole towards the solenoid.
Yes, sir, I will.
Now this rest question, 4, then 5, then 6. These 3 questions you will try again at
Yes, sir.
home, okay? And now we
Yes,
have
sir.
30 minutes. These 30 minutes we will take a test, MCQ. Only MCQ of topic 22 and 23. Is it clear? Only 10 MCQs
Yes, sir.
you will take, and your time is only 20 minutes, but 10 minutes you are getting for technical issues in G form.
Yes, sir. Hmm.
In Google form you have to do. So check it. Already I gave you. I'm showing you. Already I gave you that one here. Today's post you see. The link is there, right?
Hmm.
So I'm
Yes,
opening
sir.
it. Now it is how much? Time. What is the time? 6:30,
6:30.
right? So by
Yes.
7 you have to submit, okay?
Okay, sir.
Yes, it's now open. You can start. So we have again class at 9 o'clock.
Yes.
Okay, join at 9 o'clock. Have you got printed?
No, sir, I'll print.
Okay, you'll print. Okay, thank you, huh?
Okay, sir. Allah
Allah
Hafiz.
Hafiz.